All right, we're in Chapter 12, Quadratic Equations and Applications. So this is the last section, 12.3, on applications with quadratic functions. All right, so when we're looking at quadratic equations, remember, if we have those, they're going to be a parabola. And so we're going to have some opening down, and some are going to open up. And our vertex here and our vertex here are going to be kind of the key things we're thinking about here, because these are going to be our extreme values. And so in this case, when we have one opening down, this is going to be the max, because it's going to be the max of the whole parabola. Whereas in this case, we're going to have a minimum, okay? So the extreme value of a quadratic function is either a minimum or a maximum value of the quadratic function. And so hence, our vertex are really key on finding those. And so the extreme value is the y part of the vertex. And so, remember we had a minus b over 2a is x, and then f of minus b over 2a is y. And so this part here, that's the extreme value. And we can tell if it's going to be a max or a min based on if we look at the a values. So it's going to be a minimum value on a parabola with a greater than 0, because remember, this one, it opens up. If it opens up, that's going to be a minimum. And with this one, that's going to open down. When it opens down, that's a max value. Okay, so those are going to kind of be the key things to clue us in on if we have a minimum or a maximum. Is going to be those a values. So we're going to need to look at those, and we're going to have to also find the f of minus b over 2a to determine what the extreme value is, whether it's maximum or a minimum. Okay, and so what they might do is they might give you a quadratic function and say, okay, here, find the vertex and then find the extreme value of the function. Okay, well, we know how to find the vertex. First off, we're going to find a minus b, so that's going to be a minus 2 over 2 times a, which is 2. And so it's going to be a 2 over 4, which is 1/2. Okay, and so we know for the vertex, we're going to have 1/2 comma, and now we have to plug in f of 1/2. So it's going to be 2 times 1/2 squared minus 2 times 1/2 minus 5. Okay, well, what does that give us? That's going to be 1/2 times 1/2 is 1/4, and 2 times 1/4 is going to be 1/2. Minus, here we have 2 times 1/2, well, those cancel, so it's going to be minus 1, and then we have minus 5. So what we have is a 1/2 minus 6, get a common denominator of 2, so it's going to be 1 minus 12, so it's a minus 11 over 2. Okay, so here we get a minus 11 over 2. So that's our vertex. Now, we have a is greater than 0, so it opens up. Remember, when it opens up, what do we have? We have a minimum. So we have a minimum extreme of negative 11 over 2. Okay, and so that's our extreme value is negative 11 over 2. We know it's a minimum, and then we also have our vertex. So we looked at the a, we found the vertex, and then we also got our extreme value out of that. And so that's how we can use the things we've looked at already to kind of help us find different values that they are going to look for here. And in applications, basically, they'll give us some kind of a quadratic function, and then we have to apply what we just looked at with these. So in this case, a rocket is launched at t equals 0 seconds. Its height in meters above sea level as a function of time is given by this equation, or this function. Now, at what time does the rocket reach its maximum height? Because if you think about it, a rocket's going to go up, and then it's going to come back down, which is what we expect, because this is going to be a max value, because a is going to be less than 0. Here we have a is less than 0, and so whatever we find for the vertex part, that's going to be our max value. So we need to find two things. At what time does the rocket reach its max height? Well, at what time? That's going to be at this. So the time and the height, that's really what we're looking at here. The time here is going to be how long it takes to get to that max height, okay? And then what is the height that reaches above the water? And then round our decimal to 2 places. So we're going to have to use our calculator a little bit here. And so first off, let's find our vertex, because that's really going to be what we need to do. So it's going to be minus b, which is 271, all over 2 times a, which is negative 4.9. And if we plug all that into our calculator, well, let's go ahead and do that. So I'll show you what we're doing here. And so we're going to take a negative 271 divided by, and then we're going to take 2 times the negative 4.9. And when we get that, we're going to get 27.653 instead of 2 decimal places. So 27.65 is going to be this value. And this is going to be seconds, because remember, we said that this is t comma h. So the time is going to be our x value, and that's what we have here for t. And so now we need to find h of 27.65. And so now we plug all that in, and so we'll have a negative 4.9 times 27.65 squared plus 271 times 27.65 plus 150. And so now we'll go back to our calculator and type all that in. And so we're going to have a negative 4.9 and then times 27.65, and we want to square that, and then plus 271 times, we can just put it in parentheses, 27.65, and then we had plus 150, and so we get 3896.989, round to 2 decimal places, so that'd be 0.99. And so that's going to be 3896.99, and the height is in meters. And so that's going to be the height above the water. Okay, so our vertex is really 27.65, comma 3896.99. So that's our vertex of, this rocket launching. It goes up, hits that max height and time, and then it comes back down and then finally hits the ground here. Okay, but this is going to be our time, and this is going to be our height. All right, what about this one, the cost function? Okay, and so we have, I think, 3 different functions that we're going to look at, and I'll do each one of them twice. All right, so the cost function c of x of producing x totally cool coolers is modeled by the function c of x equals 0.005x squared minus 0.45x plus 25. And it wants to know how many coolers need to be produced and sold in order to minimize the cost. Well, why do we want to minimize? Well, if we think about this here, A is greater than 0, so it opens up, and so we're going to get a minimum value at one point, okay? And so that's what we're needing to look at, is find the minimum. And so what is our minimum going to be? Well, it's going to be, in this case, it's going to be x, which is coolers, comma, and then the other value is going to be our cost. Okay, so it's coolers, comma, cost for our vertex. And so we still have to calculate and find our vertex. So we're going to say minus b, which is a minus 0.45, divided by 2 times a, which is 0.005. And so that's going to equal, well, if we go back to our calculator, let's clear that. So we just have this. We have minus and minus is going to be plus. So really we're taking 0.45 divided by 2 times, it was the 0.005, I believe. And so we get 45. So we have 45 coolers. So that's how many coolers need to be produced. And now what is, oh, I guess it's C, sorry, not F. So we need C of 45 is equal to 0.005 times 45 squared minus 0.45 times 45 plus 25. And so now we need to go back and plug all that into our calculator. And so we're going to take 0.005 times 45 squared, and then we're going to take minus 0.45 times 45, and then it was plus 25. So 14.875, and so if we round that to the cents, because we're working with dollars, that's going to be 14.88. And so our vertex for the actual, just the function, we're not even worrying about what they are, is going to be 45 comma 14.88, and this is again coolers, and this is cost, and so it's 45 coolers for $14.88, how much you're going to sell it for. Okay, and so that's how we're going to use it to look at the cost function. And again, looking at our A helps us know that, that's the minimum. So if we find that minimum value, which is the vertex, we'll know the coolers comma cost. And like the last one, we found it was a maximum because it was a negative, and so it was opening down. And so that was how we did that one. Now we've got a revenue one. So looking at this, before we do anything and read anything, we see that A is less than 0. And so what does that tell us? We're going to open down. And so that means we're going to have a max. And so hopefully that's what it's asking for. So it says revenue R of X of producing and selling X awesome hearing aids is modeled by the function R of X equals negative 2X squared plus 62X. Notice there's no C, but it doesn't have to worry. We don't have to always have a C. This is just what we have on this one here. It says how many hearing aids need to be produced and sold in order to maximize, which we assumed that's what we was going to look at, the revenue. And what is the revenue? Okay. So what we need to do is we need to find minus B over 2A. So minus 62 over 2 times negative 2. And so if we do that one, that's going to be 62 over 4. And so that's going to be 15.5 if we divide that out. So now this is one of those things where you need to round, but it doesn't tell you you need to round. And so can you make a half a hearing aid? Not really. I guess you can make one for one ear, but we're going to assume we have to make at least 15.5. So we're not going to round this one down. We're going to round this one up. So even if this was 15.2, we're going to round it up to 16 because that's going to help us get to the next higher one. Because if we go down, we're not actually going to get close to the max. We have to be higher. So we'll say that's 16. Okay. So now we need to find what is f of 16. Well, it's a minus 2 times 16 squared plus 62 times 16. So now let's go look and see what that gives us in our calculator. So we had a negative 2 times 16 squared, and then we had after that plus 62 times 16, and that gives us 480. Okay, so let's remember 480. Now let's also do something here, and we could see if we decided not to, oops, that's okay, we'll do it that way. What if we had just said, okay, well, we're going to put in 15.5, and what if we said we wanted 15.5 here? Well, that gives us 480.5. Okay, so the actual vertex would be, so the actual vertex is 15.5, 480.5, but we're rounding up, and so when we round it up to 16, that gives us only 480. Okay, so this is the actual vertex. This is kind of the one we're assuming just based on, producing a whole set of hearing aids, not a half a hearing aid. Or what if this had been coolers? We can't produce half a cooler, so we'd have to round up on that one. And so sometimes we don't use the optimal maximum. We kind of use something that's, next best thing. And so we're going to have 16 hearing aids, and it's going to be $480 is maximizing the revenue. Whereas if we'd have done 15 and a half hearing aids, we would have maximized at 480.5. So that would have been a better number, but you can't make that half of the hearing aid. And so then we went ahead with that as our answer. Okay. All right. So I'm going to stop there, and then I'll do some more examples in the next video.